Thank you. So our next plenary session is looking at moving towards sustainable and greener dialysis delivery. And so what we're after here is experiences from real-world experience. We've got three presenters who I'll get to come up to the stage. The first, Joachim Beige, I hope I've pronounced that right, who is the medical lead of a local dialysis not-for-profit. We also have Nathan Berman-Parks, who is a nephrologist from Mexico, and then Karin Gerritsen, a nephrologist from the Netherlands. So thank you very much to all of them.
Thank you, dear organizers from KDIGO and the audience for listening. And I want to give you in these 8 minutes some small ideas or some short, fast ideas, what we did in real life with all the topics we have already heard about in the introducing talks. So the KFH is the Curatorium for Home Dialysis, founded in 1969. This was the home. Now it's only 10% home or 8%. And it is distributed all over Germany with nearly 180 centers. I'm practically working in 2 of them, and I'm coordinating in a way the medical issues in the whole organization. And I was requested to talk about obstacles and successes. And the first obstacle is obviously to take everybody into this idea to understand each of us responsibility for environmental issues and maybe take along everybody in such a huge organization. And one aspect which is not mentioned in the introducing talk, obviously it is known, but just to remember, if healthcare would be a country, it would be the 5th largest emitter in the world, and dialysis is the most important or the largest emitter within medicine. So that's the basis we have to deal with. And therefore, in a small way, comparing to this Congress here or this meeting, we did this in our organization already, a workshop about sustainability. And what we merged in a way is the scientific way, here quoted by Bill Gates, know all your numbers, deal with everything about 10% in your personal surroundings. And the other asset or the other way to deal with is a picture from Susie Knoller in the room. Many small people with many small things can change the world. And if we would be able to merge these 2 aspects, I think we can make progress. And the first, of course, is about standardization. We already heard about this. This slide is not to compare our successes in 5 pilot centers within the KFH and the German Society of Nephrology. Martin Kuhlmann shortly mentioned this venture funded by our society with the international data, but just to talk about standardization. And the larger number from the US here is basically on conversion factors, because the electrical energy in America is highly, the conversion into CO2 is higher compared to Germany, and we are not naturally 50% or 80% better than the US. We just have another energy conversion factors. And if we talk about standardization, we have to address all these issues, and this, I think, should be one point of this meeting here. So what we have done in our organization, based on the, just to show it to you, we identified 3 major issues: energy, transport, and materials and waste. And we addressed the energy by setting up solar power roofs in right now 8 centers. There's a plan of around 20. And again, to obstacles, we have to have such good roof surfaces, mostly flat, not divided roofs or something like this. And of course, we have to talk about the investment. This is my only unit. It was an investment of 150,000 euros in several steps. But as you see here, we are now from this season energy sufficient as a self-sufficient. Obviously not all over the time, because the sun is not shining all over the time, but on a sunny day we can dialyze on our own energy starting from March, April throughout October. So this is obviously a very major point, even economically. And the other thing goes about saving of energy and saving of water. And we had a huge company-wide discussion about reducing dialysate flow. The example here shows you this from a center perspective, the left side of the slide, and also calculated on a patient level. So we recommended to set all machines to a preset of 350 milliliters per minute, but obviously recommended as well to address the patient's individual medical issues. And if the doctors and the team thought that there were several medical issues to raise the flows, of course they were allowed or should raise it. And we ended with a reduction in about 70% of patients and a reduction of water consumption and energy of about 10% in each center which did it like this. This is the left side, and the right side is the company-wide effect of that measure, and we saved company-wide 730 tons of CO2, and by the way, 200 to 300,000 euros, company-wide in all 180 centers. Obstacles, of course, you have to deal which patient are suitable for those measures. So is there certain guidance, recommendation, even guideline? No, it is not. We just recommended to preset the machine. We not recommended to preset any patient standard. So this is the individual doctor's decision. But the other way around, we have to talk to the patient. I personally think there's no medical problem, but some patients do think so. So I had tough discussions, not with our own patients, but with patients from our side. So the only thing is to save money, yeah, but that's not the only thing. The thing is to save the environment. The only data we have about patient is on phosphate levels before and after doing that step. And more people decrease their serum phosphate than increase. Maybe this is sort of biased, but obviously we have gone for patients with residual renal function, not so large, not so heavy, no high blood flows. So we did it only in those where we thought that detoxification is not a mass need. And obviously, looking at these data, we were successful. Another big issue is obviously waste. This is again a picture from Susi from Bremen. And at waste, we have in Germany at least, and I think it's quite unique, to look at this need to burn or to incinerate the waste. So this is the current situation. We have to burn it. So it's by rule not allowed to do it other way. And we have to overcome this by steps of disinfection and by material keeping recycling steps. So whether we can go for reuse, as in America 20 years ago, or we can keep the material. So these are I think these are technological questions we have to address. Third and last is transport. We can use our solar roof for electrical cars. This can be very successful. Sorry. So I'm just done. We can educate patients for group standards, group transports, and we can stimulate our staff to use non-fossil transport. So this is concentrate mixing. So this is just an example. I skip it because of time, and this is nutrition during dialysis. Again, healthy nutrition, healthy planet. Example by Susi as well. And my last slide is my first patient in 1995 when I met them, and he used dialysis recycling 20 years already. So he had this very nice small car with a small dialysis machine with dialysis recycling starting 1970. So my last obstacle is Back to the Future. Karin Gerritsen is in the room, yeah, and we will hear about this. Here are our results, what we reduced already, and what we have to do, obviously, is upscaling in all of our 180 centers, and these are the next topics for the time coming. Thank you to all the collaborators or the activist group in Germany. This is the thanking picture for all of them. Thank you for your attention.
Thank you. We'll have questions at the end, so we might sit down and Nathan, get you to come up next. Thanks so much.
Fine. Yeah.
The next slide is here.
Sorry, I'm supposed to. Okay. Yeah. This one, perfect. Okay. So thank you for the KDIGO for the invitation. I'm really honored to be here, and in interest of time, I'm going to start. These are my disclosures. I'm the co-founder of a civil association that I'm going to talk about. So this year we're going to have worldwide 5 million patients receiving any kind of renal replacement therapy. And what that means to the world is that we're going to produce almost 2 billion tons of waste, most of it from HD and, well, 10% from PD. And, is all the waste that we produce the same? So this question was answered by this seminal paper in 2005. And in this paper, it's stated that most of the waste is composed of PVC. So it's almost 60% of the waste is PVC based. But what is PVC? We are not chemical engineers. Well, at least I'm not. But PVC is a thermoplastic polymer. That means that it can be heated and reshaped in other products. It's really cheap, so it's present in 1/4 of medical devices. It's very versatile, and it's one of the most produced plastics in the world. So we have to learn a little bit about the life cycle of the PVC. So the primary material of the PVC is salt. So when you put electricity through salt, you are going to get sodium that is needed for the caustic soda industry. It's like if you want soap, you would need caustic soda. So one of the byproducts of this reaction is chlorine, and chlorine is really toxic to human beings. And the chemical industry has managed ways to use this chlorine and to put it with ethylene. So when you put it with ethylene and through many chemical reactions, you would get the vinyl chloride. That's the monomer, the building block of the PVC. And in order to get the PVC, you would have to transport this monomer to a PVC production facility. And then you can polymerize this monomer and get finally the PVC. In the process, you're going to consume materials. So you're going to consume water, electricity, and also emit CO2. And once you get the PVC has a really rigid structure, and it's a really hard material. So it's not the PVC that you see in the hemodialysis units. It's like a hard plastic. So then you have to transform it, and it would have to go to a compounding factory where you have to add some materials. One of the materials that you add are plasticizers, and one of the most used plasticizers is phthalate. And phthalate, it's been known for being an endocrine disruptor and maybe a carcinogen. So as you can see, many of the things that PVC is composed of are toxic, so there's no one. Sorry. And after you consume the PVC, then you have to discard the PVC, and we have touched this issue in the last presentation, so you're going to have dioxin emissions, phthalate leach, or microplastics. So there's no wonder why some governmental organizations have termed the PVC as poison plastic. And many of the PD providers are moving away from PD and using non-PVC based components, but nevertheless, PVC is a cheap material. It's being produced, and it's going to increase the production, and half of the PD materials are still based on PVC. So maybe it's not about the plastic, but it's about us, no? It's not It's me. It's the way we are managing the plastics. So we are used to a linear economy when everybody knows about this. So can we turn it into a circular economy? That's the question. So is this possible with PVC? The short answer is yes. There are many ways to recycle PVC. So, and one of the, I have this. So one of the easiest ways and cheaper ways to do that is just a mechanical recycling, where you can shred it and you can heat it and convert it into other PVC products. So it's really easy to do. And but the question here in a dialysis conference is if we can do that with the PVC waste from renal replacement therapy. So in HD, we know that only 15% of the weight of the waste is recyclable, and only 1/4 of that weight is made out of PVC, so it's not a big source of PVC. But what about PD? So in PD, we know that we have a lot of material. Every patient, as Janelle showed us, is going to produce around 100 kilograms of PVC per year, a recyclable PVC, non-biohazard PVC. That means that around the world, our patients are using and then wasting 30,000 tons of PVC per year that can be recycled. What are we doing about this? So, like in the medical literature, there's not a lot of information, but once you go through the internet, you can see that in Australia, there is a program going in a partnership with Baxter and Vinyl Council. In Colombia, there's another association called Vinyl en Movimiento. And finally, in Guatemala, there's an association called Biotrash that's recycling also PVC. But well, I'm from Mexico, and what are we doing in Mexico? So that was the question I asked. And so I decided to start a feasibility pilot study to see if this was possible in Mexico. So what we did was we partnered up with an APD clinic, and then we just went with the patients and told them, like, just bring back the waste. So the waste was gathered, then weighted, and after that it was sent to a recycling facility. In the recycling facility, so all the waste was washed with bleach. Then the APD waste was separating between PVC materials and non-PVC material. Here you can see a picture. So it's almost 300 grams of PVC per every kit. And then the processing of the PVC is really easy. We just shred it, then we dried it, and then we send it to a compounding, thermoplastic compounding factory. This is what they are doing with the PVC. They are incorporating into the production of new PVC pellets that can be used in the production of final products like garden hoses, cable coating, and shoe soles. So we did, for a 20 APD clinic, we did manage to convince 60% of the patients to join our program. We did gather almost 17 kilograms of waste, and 60% of that waste was PVC in 1 month. And so, yeah, the question is, can this be financially sustainable? So the short answer is yes. In order to recoup the investment in 5 years and then to keep on going with this program, we would have to include almost 350 patients. That might seem like a lot, but it's less than 5% of all the APD population in Mexico. We did find some hurdles that we have to, some challenges. So as Janelle told us, storage and transportation of the waste can be really difficult. The separation, when you get all the waste, can be labor intensive, and PVC is cheap. So there's a need to recycle large amounts of PVC in order to be sustainable. But we are finding ways to overcome those challenges. So one is the APD material is brought to the patient, but the truck is going back to the warehouse empty. So maybe the APD material can be also collected, and this is done in Australia in a partnership with the Baxter company, but just in Australia and Mexico, we couldn't convince them to help us. Then the PD, the separation of PVC can be incorporated into the PD procedure. And finally, there's a trend to add some value to recycled stuff and to have, to not see it as a second-hand thing, so it's like a more a valuable product. And is this environmental, is healthy for the environment? So the short answer is yes. We did do an assessment, and we can save up to 13 liters of water for every kilogram of PVC recycled, 21 kilowatts per hour of energy, and avoid the emission of 5 kilograms of CO2 without the obvious spillage of phthalate, dioxin, and microplastic. You can see the details in this paper. And this has been associated with a reduction of the CO2 footprint of about 15 to 30%. And something important, is this beneficial? I mean, it's good for the environment, but is this beneficial for the patient? Yes. So disposing of medical waste can have a real burden in the patients, and the patients are interested in participating in this program. And there's an unmet need for repurposing or the disposal of unused PD supplies. So this is our association, and we have been doing, let me put this video shortly. We have been giving trash can bins to people, and we have been collecting all the waste. And this is the way we have been marketing. And with this social networking, we have been able to include 150 patients up to date. And the last months, we have managed to collect and process 2 tons of PVC per month. So establishing a recycle program is feasible. It can be environmental and financially sustainable, but we do need the collaboration with the industry and the PD providers, and also to engage with the PD providers and the patients. So thank you for, I think.
Thanks so much, Nathan. That's amazing. Karin, we'll get you to come up next.
Thanks a lot for providing the opportunity to tell something about our experiences in Utrecht. We are just starting, so we can learn a lot from you. But just some first results. Here are my disclosures. I received some research funding from Next Kidney, and I'm collaborating within the Kidney Care project. I'm the medical lead with several companies, only for research purposes. And we, at our dialysis department, we defined 4 objectives. And due to time constraints, I will only cover the water and the energy, the waste, I'm sorry. First, the water issue. So thanks to Peter Blankstein, we actually have quite a nice modern RO system. From B. Brown, it was, we have it since 2021. And here we already do re-injection of the excess permeate and re-injection of the RO reject water. And we have a recovery of 66%, where we use a concentration factor of 3. So when the conductivity of our reject water is 3 times that of the softened tap water, then a valve is released, this valve there, and it opens, and then our reject water is released. And we did a very elaborate measurement of the water flows and also of the energy, and actually found that the RO system accounts for 61% of the energy consumption. And we made an optimization plan. So we also found out that our conductivity sensor continuously reports values that are below the level of detection, so below 0.5 microsievert per centimeter, while conductivity of the permeate up to 10 microsievert per centimeter is allowed. We have very clean water actually in Utrecht, I think perhaps the cleanest water in Europe. Our water is also used for the bottled water from Bar-le-Duc. So we thought we can perhaps easily increase this concentration factor from 3 to 5. And in this way, we can increase our water recovery to 80%, while we are still far below the maximum allowable level of the conductivity for the permeate. And then we found out that actually our permanent hot disinfection time, where the water of 90 degrees circulates in the ring line, is quite long, 40 minutes, while according to the ISO standard, only 10 minutes at 80 degrees is required. So we will also lower the PhD time to 50 minutes. And we do disinfection every night, while that is not necessary. According to the guidelines, once in 3 days is sufficient. If you also do, for example, citric acid sterilization of your machines. So we will also reduce the frequency to 3 times a week with a very elaborate validation plan. Then we found out that our RO system produces 2,000 liters of permeate per hour, while we only need 800 liters at max for our 17 hemodialysis machines. So we have a very small unit, actually primarily for acute hemodialysis. So we intend to implement a monitoring system, performance system from Green Tech. That's Green Tech collaborates with B. Brown, that can adjust the pump rate to the needs, the actual need at that moment. And also, we will also probably incorporate a heat exchanger upstream of the RO system that already heats the incoming water. And in this way, we can reduce the energy consumption also with estimated percentage of 30. Then the reuse of our reject water. So we release 22,000 liters of reject water per week, and we did an analysis of this reject water, and it's actually still quite clean. So it has a low conductivity, below 1,500 microsievert per centimeters. So it's actually suitable for watering of plants, and it does not have any content, any solutes that can precipitate, no calcium, no silicate. It has a low salt concentration, a neutral pH, a low nitrogen content, and a low organic carbon content. So we can easily use it for all kinds of purposes. And we are going to rebuild our dialysis department at a new location. So now in the design of this department, we implemented the reuse of our reject water for flushing of the toilets, where it's important that the last toilet in the row is a toilet that's being used quite often, because otherwise you get Legionella, a risk of Legionella infection. And we previously had that because there was a previous attempt in our hospital to reuse RO reject water from the central RO installation, and there we got Legionella infection. So now they're very keen on, and they're very careful that this last toilet in the row is one that is being used quite often, because previously it was a shower at the end, which was not used by the patients very often. So then they got a Legionella infection. Then reuse of spent dialysate. We're just exploring this. It's different than with the RO reject water, of course, because we need to remove pharmaceutical residues, waste, toxins, and also nutrients before we can reuse it. We did an inventory together with the Wageningen University for the solutes that we need to remove. And there are actually a lot of ecotoxic residues in the dialysate. We did some measurements, and we found, for example, bisoprolol and prednisolone, furosemide, and it's just ongoing. We first focused on the solutes that had most priority, highest priority, because they are persistent in an aquatic environment or very ecotoxic. And now we're exploring together with an engineering company whether we can apply technologies, wastewater treatment technologies that are being used within industry, also in the hospital. But we are just starting this initiative. And I think Faisal can tell much more about this, so I will leave that up to him. Then the reduction of dialysate use. Of course, there are obvious measures like using autoflow or EcoFlow, or currently we have the practice to turn off our machines after priming before we start dialysis. But I'm also involved in the development for more than a decade of 2 regenerative dialysis devices, one for PD and one for hemodialysis. With the PD device, we are currently doing the first in human trial, and with the hemodialysis device, that's an initiative of the Dutch Kidney Foundation. It's a new kidney device of Next Kidney. The first in human trial was just performed last year. And we just submitted the documentation for a pivotal trial, a pre-market pivotal trial. Focko will come to that later and we'll discuss the technology. And of course, we only use a very small volume of dialysate, 4.5 liters. We make use of sorbents, immobilized enzymes, but we don't know the footprint of this, and perhaps the footprint of these materials may negate the benefits of reduced water use or reduced energy consumption. So we just started within Kidney Care a life cycle analysis on this. Then reduction of waste, just some brief examples. Also, thanks to Peter Blankestein, we have now central acid delivery using a dry concentrate powder, system of B. Brown, where also the containers with a dry concentrate powder are being returned to the supplier to be refilled. Fresenius has a comparable system, Craniumix, and Professor Donati and Gaetano Alfano, and also the group of Brad Duane, James Larkin, just did an LCA on this, and we're also doing an LCA on our change. And there's a significant reduction in the footprint of dialysate when you use central acid delivery with dry concentrate powder, but probably Professor Donati will tell more about that later. And then we're also exploring whether we can find an alternative solution for the bicarbonate cartridges. So together with this engineering company, we are working on the design, feasibility studies, and risk analysis of 2 approaches: to use a carbon dioxide blanket to stabilize the bicarbonate solution, or to do inline dilution with a reservoir with sodium bicarbonate. They apply this already in the pharma industry, but we are going to investigate whether we can also explore it in our new dialysis department. And for the sterilization, we intend to apply the same procedures with the RO system. And in the meantime, we are together with our compounding pharmacy, A15, exploring whether we can reuse the cartridges and refill them. Because they are a compounding pharmacy, they are allowed to do that. And then you can also individually dose the bicarbonate, the cartridges, because currently there's a lot of bicarbonate left in the cartridges before we discard them. Then this initiative, Focke will also talk about this, reuse of dialysis. So within the near future, we will get an FDA-approved machine from Novaflux to regenerate dialysis, which makes use of a sustainable process for regeneration of dialysis. Focke will come to the technology. And together with our technical department, that is ISO 13485 certified, we have a complete plan to work towards CE certification. So testing, feasibility studies, and we will also cover the regulatory issues. Actually, it's allowed, according to the MDR, to reuse single-use items. And depending on your national regulations, you can apply that. You may be able to apply that. We just had a change in our regulations in the Netherlands, so now we are allowed to do this, but we are exploring together with the Dutch Standardization Institute how to do it then. The LCA, I think Focke will come to that. We did an LCA on this within Kidney Care. So a lot is ongoing. So hopefully within decades, we hope to improve the sustainability of dialysis at our department, and therewith also lower the burden for not only the environment, but also for the patients. This is a picture of Focke. So thanks a lot.
Thanks so much, Karin. They were all fantastic presentations. Hands up already, Caroline.
Yeah, hi, Caroline Stigant from Canada. Thanks, everybody. So exciting to hear about all the innovations and hugely jealous. In our area, we're really struggling with what we'll call infrastructure projects, and one hates to put an added burden on people who are already pioneering and doing so much, but I reflect that especially return on investment type of data, or some sort of demonstration of environmental cost savings will help other areas adopt these technologies. And I think ultimately it's great to have an infrastructure in place for everybody to be on board so that we can expand these things when they're ready to fly. I'll put a plug in for the ISN Green K, which I've been very privileged to be a part of. And we're partnered with Center for Sustainable Healthcare, and probably many of you know that there's helpful case studies on there, and they've got some of those cost savings benefits. But I wonder if that might be feasible to include the cost benefit. The very first case we heard of there was your look at solar panels, and we thought that would be so great to put on all of our units. Let's do this, we're going to save money, and yet the capital money isn't flowing. So having more experience of the savings would be fantastic.
Thank you. While waiting for other questions, Ben.
Hi, thank you all for such great presentations. My question was to Nathan, and what you've done looks amazing, and it looks like that's really because you've been engaged and you've driven it forward. And I guess my question is, who do we target or apply pressure to or encourage to roll that out on a broader scale? Like, is it industry, is it government, is it healthcare providers? Like, with your insights, where would you recommend we put the energy and the emphasis?
Thank you, Ben, for your question. Yes, this is a question I was hoping for. So yes, this effort is, 150 patients in Mexico. It's me, my sister, my father, and that's it. And it's not enough, definitely. But yes, as they do in Australia, where the place of birth of the green nephrology, I think maybe Baxter Australia was interested in providing that service because it's something that people are talking about. So we are the consumers, and they have to sell us things. So if we as consumer need something, so the one that the provider is going to try to provide. So in Colombia, like the PVC industry was the one that was pushing, like, to greenwash the PVC. And in Guatemala, from what I heard from Biotrash, there was this environmental catastrophe where they saw like Baxter bags in a river or something like that. And Baxter needed to greenwash a PR stunt so they could say, we're helping the environment. In Mexico, we haven't had that, fortunately, an environmental disaster. But yes, like if it's not valuable and if they are not making money out of it, that's my take. It's sad. But yeah, I think we are the consumers. So we have to say to the industry, we're not going to buy your stuff if you're not going to provide us an alternative of what are the patients doing with this. So yes, I have been in talks with Baxter, but they are not interested because it doesn't make a difference to them. But if we as a community of nephrologists can say, like, no, we need a solution, we're not going to keep buying and recommending your stuff because you're not providing the solution, maybe we can put pressure. And maybe also from the government, they can, in Mexico, we have this consolidated buys of material. So maybe when they put in a bid for providing the PD material, but what are you doing about the environment? We're doing this. Okay, so it's a thing that we can consider and maybe paying a little bit more, but like helping the environment. That's my take on that. Thank you for the question.
Jane?
My question was also to Nathan. Amazing project. I am in an area of Australia that isn't supported by the Baxter PVC recycling. And a lot of the projects that require a lot of manual labour, and I saw that you showed that it was financially viable, but are dependent on minimum wage as well and volunteer access. And I was wondering if that was something that you assess, because these things become less viable in countries where the minimum wage is higher, and that's where we have trouble as well.
Yes, for sure. Well, in Mexico, the minimum wage is lower, so it can be financially sustainable. But still, I think the manual labor can be reduced, like with the, I know that the patient have a big burden, but maybe we can have like this easy, I mean, we did this video, it takes less than 1 minute for the patient to separate the PVC component and the non-PVC component, so that could lower the manual labor into this recycling effort, and maybe this could lower the price and make it sustainable also for other parts of the world. Well, at least in Mexico, it's still sustainable if you can manage to gather like more than 3 tons of PVC per month. And also, we're hoping to increase the value of PVC, like in like a marketing stunt, like, oh, this is helping the environment. You can buy it like for $2 more, like it has the increased value to help the environment.
Raymond?
Yes, thank you. Were very interesting talks. Actually, my question is to the three of you. One of the problems I think we are facing is that the regulations are different everywhere. If I'm talking for the European Union, they are quite severe, but then each country then still puts on sub-regulations, which makes it more difficult. So we, in a certain sense, we are needing a more standardized system for regulations all over the world. But then on the other side of the coin, there is also a lot of labor involved, like what you're showing for Mexico. There is a labor force involved. Labor force is different in cost all over the world. So there is a need also to adaptations because of local conditions, I think. So on one hand, standardization, on the other hand, also flexibility depending on the conditions.
Concerning
Don.
on the standards, so just come to, if we talk about Germany and incineration again and burning, I think it's a question for scientific work, because we have simply to do studies to show that disinfection, microwaves whatsoever, is effective to take out the harm of blood-contacted materials. And if we're going to present the results of such work to the regulative authorities, then we can argue then, okay, go to reuse those materials and not to burn it. So there is a task to us, maybe a connection between technology and medicine, and integrate infectious disease specialists and so on. So this is the one thing. And the other thing, in terms of labor force, cost and standards, I mean, there's from an economic point of view, a very easy solution. Put a price on waste. But obviously this price would affect us all, not only in the dialysis unit, but in the home trash bin as well. But if we talk about pricing those waste treatments, then the economy is completely different. Yeah.
Just to note that we don't incinerate waste in my home state of Australia, so it's not widespread as treatment of medical waste. It's different around different parts of the world, so the evidence may already be there. Jeff?
That was great. What about the economic and cost impact of starting with non-PVC to begin with for PD solution bags, for example, compared to a PVC recycling program?
Yeah, I mean, well, in Mexico we don't have, at least that I know of, non-PVC. From what I have read, there was this editorial in 2021 from, I don't remember the name of the author, but he said that...
Mark Marshall.
Mark Marshall, yeah. PVC is really cheap, so when the other producers were going away from the PVC, the prices started to increase. And there was, like, the PVC providers also increased the price, so it made, like...
yeah, so that's the
PD,
question,
yeah.
the cost effectiveness of PVC plus a recycling program versus non-PVC.
We haven't done that, but I think it's cost effective. I mean, I know PVC is really satanized, and maybe moving away from PVC, it's the right way to go, like in the future. But nowadays, at least 50% of the PD supplies are PVC, so we do have to find a solution for today. Yeah.
In the interest of time, we better move on, but thanks so much. They were fantastic presentations.